So we have an object moving in a straight line. We're moving on to forces now, the last part of the exam. Straight line, constant speed. So what happens? Let's be clear. We haven't studied work yet. That wouldn't be an answer. No forces act on the object? No, we can have forces acting on an object and it moves at constant velocity. The momentum, we haven't studied momentum yet, but now that you've studied it in class for one day, you know the momentum isn't zero since it's m times v, and v is clearly greater than 0 here, so that's not true. No net force acts, meaning we can have forces acting, but they ultimately cancel. Oh my goodness, we have the lift. Oh my, that British language, those wacky Europeans with their lifts. Okay, that's just crazy talk. Okay, so we have the normal force from the scale, and then we have the weight of the person, so we have the reaction normal force minus the weight of the person, and the effect is that the mass accelerates upwards. I'm going to leave that as a positive acceleration since it's upwards. So I'll say the reaction minus 600, the reaction normal minus 600 equals, now their weight is 600, so 600 equals mg, 600 equals m times 10, so the mass is 60 kilograms, so 60, and the acceleration is 1. So when I actually read the weight on the scale, it's not the weight on the scale, when I read the reaction force that the scale registered, I'm actually going to get 660 newtons worth of force. Pretty obnoxious there. You see how they give you the weight, and then you have to get the mass from that? I'm telling you, weight and mass, that distinction, it's killer. Okay. A speedboat tows a water skier so that the skier accelerates. So the force exerted on the skier by the tow rope must be equal in magnitude. This is the only must, okay? But let's take out the other one. Equal to magnitude of the force causing the boat to accelerate. Actually, probably going to have to be smaller than the boat force. And then greater than the total resistive force acting on the skier. I'll go with 1 and 2. 3, not necessarily true. It actually needs to be less than. Because if it were equal to that boat force, no, you just can't do that because it's just a small little skier. And you can't really guarantee. Maybe it is equal, maybe it isn't. Maybe it's less, maybe it's greater. I'd need to see some numbers for that. I just don't trust that one. And then for 1 and 2, got to be greater than the resistive force that the skier can accelerate. And for this is the third law. So this is the third law, and then this is the second law to get it to accelerate. All right, and then question 18. A force acts on this block. I had a lot of questions on this one. Let's be really careful. So most people were able to eliminate A and B. Check this out, though. Look at the length of this vector versus that vector. And let's be really careful. And also, let's look at the length of these vectors here. So what we're saying is the upward force comes from part of this and part of that. So we have a total upward force like this if choice C is correct. So we actually need the normal reaction force to be a little bit less so that this upward rope and this are the things that balance the weight so it doesn't leave the ground. In other words, we're pulling up a little bit, so the reaction force is going to be a little bit less than the weight because it's not on the ground as heavily. Number 19. If we've got a car going in a circle, the force is always directed towards the center of the circle. That was a big key one that we talked about. And then for number 20, we have a diver falling at constant speed. So check this out. We've got a drag force going up. We have the weight force going down. Let's be clear. So the weight is going to be 80 times about 10, which is going to be about 800 newtons. So that means the drag force has to balance it, and it is also 800 newtons. Finally, a model plane flies with constant velocity at constant height. What does that mean? Constant velocity, forces balance. That means D is the only possible choice for forces to be balanced. So those are our force questions, our mechanics, our motion questions, and our measurement questions. So that, dear students, is exam number 2 of the year. Hope these solutions were helpful.